The only person I've talked to today is myself. Well, and Coach Fritch. All right, so 5.4 today. I think it's going to help with kind of what we did on that Halloween activity. We looked at some probability that we hadn't quite used before. So I think this will help a little bit. So this one says, who has pets? In one large city, 40% of all households own a dog, 32% own a cat, and 18% own both. We want to make a Venn diagram to display the sample space of the event. So just because it's been a minute, let's walk through this. When we do a Venn diagram, all right, we've got two different categories. All right, so we got our dog people, our cat people, our both people, and our neither people. All right, so there's always 4 blanks to fill in, okay? The one you want to start with, okay, is your both, and we're going to use decimals to do that. So my both was 18%, okay? So what's going to go in that middle blank? 0.18, okay? So we always take the both, put it in first, all right? And the reason we do that is because 40% is my total for dogs, but 18% of that also have a cat. Okay, so how are we going to get the number for dogs?
40 minus 18.
40 minus 18. Okay, it's going to give me 22%. So what decimal would that be? 0.22. Good. All right, and then we're going to repeat that for our cat peeps. Anybody got a cat in here? I like cats, but I don't own one. You don't like cats? Okay, some people don't. Okay. Then it says 32% own a cat, but we've already counted 18 of that percent. So 32 minus 18, is that 14%?
Yeah.
Okay, so that would give me 0.14, right? Now, those are the only numbers they gave me, but could I figure out the total number of people that I've not included?
Yes.
What would I do?
Add all of those together.
Yeah, let's add all of those together. So I've got 22, 18, and 14. So 10, 14, carry my 1, 2, 3, 4. That's 54%. All right. And then how would I get what's left over? Yeah, 100 minus 54, which should give me 46%, which would be 0.46. And so that is my Venn diagram. That's my entire sample space. When I do a Venn diagram, if I add up all the dots and the 3 in the circles and the 1 outside, it should add up to 100, all right, or to 1 if it's all decimals. Okay? Question about that? All right, rock and roll. Well, today we're going to talk about conditional probabilities, and we did a little bit of that last week on that Halloween activity using those tables that we've done. And then there's a formula for conditional probability that I'm going to show you that's useful sometimes if I know certain things. And then we're going to figure out if 2 events are independent. That's something that's an important skill for something later. Okay? So remember when we did the taco tongue and the evil eyebrow? Yep, we talked about that. So let me pull that class data back up and let's fill in that chart. So we had 15 that could do both, 5 that could do the tongue but not the eyebrow, 3 that could do the eyebrow but not the tongue, and then 7 that couldn't do either, right? And our total was 30 students. Okay, so 20 and 10 when I add across, 18 and 12 when we do those totals. All right, so that was our data from the last time. Okay. All right, so let's jump in here. So it says, given that the person selected is yes to the evil eyebrow, what's the probability that they are a yes to the taco tongue? Okay, so we want to do it as a fraction, a decimal, and a percent. When we're looking at probabilities like this, all right, it says, given that they are a yes to the evil eyebrow. Okay, does that mean that I'm going to consider all 30 students?
No.
No, I'm only going to consider these students that are part of the evil eyebrow. Okay, how many total students are part of the evil eyebrow? 18. So total evil eyebrow, okay, which is going to give me 18, right? And then out of that list, in my numerator, I want to choose the number that says they are also yes to the taco tongue. So how many were yes to the taco tongue?
15.
15. All right, which was 15. So out of that list, I'm choosing those 15. So if we wanted to write that as a decimal, what would we do?
Divide.
We would divide. So that's 0.83. And is it repeating?
Yeah.
And then that would give me about 83%. Okay, so a fraction, a decimal, and a percent. So we're changing the denominator, and we're no longer considering the total number of students. We're considering just the total people that can do evil eyebrow. Okay, so let's repeat that process a little differently. It says, given that the person selected is a no to the evil eyebrow. So let's go over here and let's figure out how many of those people we're talking about. Okay, so no to the evil eyebrow is going to be my new denominator. So total no evil eyebrow. So I'm going to do total no. All right, how many people is that?
12.
12. Okay, so my denominator is going to be 12. All right, then of those 12, what's the probability that they're also a yes to the taco tongue? 5 at the top are yes to the taco tongue. So we're just reading it from the chart. All right, and so when we do that decimal, about 42. Yeah, I would too. About 42. So give me about 42%. Okay, that is known as conditional probability. Okay, and we did a little bit of that on Halloween. Okay, conditional probability. Okay, and what conditional probability does is it changes the denominator. Okay, we no longer take the entire total number of students. We just take a smaller group, okay, of the total. So when we do conditional probability, it changes the denominator from the total. Okay, so we're not going to do the final total, we're just going to do a smaller portion. Okay, it changes our denominator from that total number. Okay, now how do we recognize when it is a conditional probability? Well, there's one word we're going to always look for. Okay, and it's this word right here, given. Okay, given is the word that clues us in that it's conditional probability. Okay, we're going to make a smaller group of students. All right, we're going to make a smaller group of fourth graders, right? So we're just going to make a smaller group. The wording and the symbols that we use for conditional probability, this might be represented like this. Okay, probability that we can taco tongue given that we can evil eyebrow. Okay, the second one is always my denominator. Okay, the first one, right, comes from that second group. Okay, so it can't be outside that group. So the first one is going to be comes from the second group. Okay, so it has to come from that group. That's our second thing. Right? That bar means given. Right? So this would be, if we wrote it in words, the probability that we can taco tongue given that we can evil eyebrow. That's a mouthful. Okay, but that's how we would say it. It is the probability that we can taco tongue given that we can evil eyebrow. All right, so that's just the symbols. Right, when you see that bar, it means we're going to limit our total group. We're going to take a smaller group, and then I'm going to choose something from that group as my numerator. Okay, so it just limits everything. Okay. So now it gives me a definition. It says that two events are independent. So that's a big word. All right. Are independent if knowing whether or not one event has occurred does not change the probability that the other event will occur. Okay. So independent meaning one probability has no effect on the other. All right. So it wants us to try to figure out, are the events yes to the taco tongue and yes to evil eyebrow independent? How might we check? How might we decide that? Okay. I want you to look at the data that's in that chart. Okay. What do you notice about the people that can do both? There's more of them. Okay. So because there are more in that both category, chances are those two things are not independent. All right. There's probably a greater likelihood that if I can do one, I can do the other. Okay. So the data shows me, all right, the answer would be no, that they're not independent. The data shows more people can do both. Okay, and we're going to get to a formal definition for independence. How do we prove it mathematically in just a second? But a lot of times we can just look at the data. All right. So now that we've kind of walked through all of that, let's just practice some of this probability, okay? Because for a lot of us, I don't know about y'all, I hated probability when I was in school. Like, it's taken me having to teach it to finally get some kind of appreciation for it. So you're not alone, okay? All right. And there will be times we'll be working through stuff and I'll be like, yeah, I don't know. Okay, I'll have to go look it up because I don't know. All right. Just be honest with you, okay? So let's take a look down here. So they give me some different data. Okay, still, how many students total in this class? 30. Okay, so still 30 students total in that class. All right, so let's look at these probabilities. The first probability that they want are yes to taco tongue. So that's the only thing. Okay, how many people are yes to the taco tongue total? 24. There's no bar, so we're not going to limit my total. How many total students are there? 30. Okay, so we keep the total because there's no bar. All right, so 24 out of 30, I believe that'd be 0.80. So about 80%. Okay. All right, so now let's look at the next one. Okay, on the next one, it's got that bar, that given. Okay, which means I'm going to change my denominator. Right? So my denominator is going to be my total people who can evil eyebrow. So I'm looking at this column. How many total people can evil eyebrow? 10. Out of that column, how many can also do the taco tongue? 8. Okay, 8 out of 10. All right, which would give me 0.8 or 80%. All right, let's go the opposite direction. All right. What about the next one? It's got the bar, so it's going to change my denominator. Okay. How many total people can no to the evil eyebrow? 20. Out of that column, how many are yes to the taco tongue? 16. Okay, which is 0.8 again. 80%. Okay. So it says, do we think this time that yes to taco tongue and yes to evil eyebrow are independent for this class? Yeah, I'm going to say yes to. Okay. I'm going to say yes to. Let me show you why. All right. Let me show you why. There are two probabilities that they have us look at. Okay. Or actually 3. First, the probability that we could do the taco tongue, okay, has to equal the probability that I can do yes and yes. So taco tongue given evil eyebrow, but it also has to equal the probability that I can taco tongue given that I can't evil eyebrow. How do we say not? Do you remember?
With little C.
The little c. Okay? So if those three probabilities are equal, then those events are independent. Okay? That's the mathematical proof for that. You might see it written this way. Probability of A would equal probability of A given B. So just my two events. Probability of A given the complement of B or not B. Okay? Remember that little c means not. Okay? So that's kind of the formal mathematics to how that looks. Okay? So if we want to prove that things are independent, again, looking at the data, okay, if we look at the yes taco tongue and the yes evil eyebrow, 8 is not my largest number in that table anymore. Okay, so I think that really kind of shows us data-wise, but math-wise, we have to prove it by checking those three probabilities. Okay, that's how we prove independence. All right, flip that bad boy over. Let's organize our thoughts. We're going to do a few examples, and then we're going to rock and roll for today because it's Monday and I'm tired. All right. Y'all feel that? Yep. Some of us are tired every day, but that's okay. All right, vitamin C, B12.
I felt like I gained an hour instead of walking around.
I know, me too. About 5 o'clock last night, I was ready to go all the way to bed because it was dark outside. Yeah, but I was at Walmart. Let me just tell you, if you really want to see the people of Walmart, go at dark. That's all I have to say about that. There's definitely a difference between when it's daylight and when it's dark at the Walmart. Okay. And the Halloween's like 70% off, so go get you some stuff. Okay. You didn't get enough candy. All right. At Kroger, it's 70% off. I was there too. All right. Because they have the best yogurt. All right, let's look at this. Okay. All right, so lesson target 1 was all about our conditional probability. Okay, conditional probability. We know it's conditional when it uses the word given. Okay, and we'll see it written like this: probability of A given B. Okay, B represents my smaller group. A has to be part of that group. Okay. So my conditional probability. And it's like a sideways written fraction, okay? The numerator's first, the denominator second. Okay. Now, it talks about the conditional probability formula. I don't focus on it a lot, but I want to show it to you, all right? And this is what it says. If I want the probability of A given B, okay? It's basically the probability of both things happening over the probability of the second. Okay? So it's the probability of both over the probability of the second. And the way we get that is probability of A and B. We would add those things over the probability of B. And that's kind of the notation you'll see. Remember we saw that big U last week and it represented or, maybe the week before. They also use this. It's a U, but it's upside down for and. Okay? The way I think about it is right there. Okay? That's how I think of it. Grab you some lunch.